Hello guys, good morning. In this whole video, we will discuss about TCP header, but this is the sequence wise video. Now we have covered more things such that source port, destination port, this is a 16-bit field, this is a 16-bit field, this is a sequence number here, a 32-bit field, acknowledgement number 32-bit field, and this is the more important information about we have covered a sequence number and acknowledgement. This is the this is the backbone of TCP header. Every point here, this is the very important point, and we have covered. Now we will tell you more detail in data offset. About what is the data offset, we will tell you. Clear? Now, so let's start. Here guys, what do you understand about TCP here data offset? First point here, this data offset, suppose that this is a do here, data offset, it indicates in layman language we can say that it indicates indication of a row. It indicates row. It is used to indicate row. So we can say, we can write to indicate row. Now we can say to indicate 32-bit words. To indicate 32-bit words. Now here we will write here, suppose 32-bit words. Now here we can say that it represents that TCP header is an integer multiple of 32-bit long word, that means length are 4 byte. Here we can say that 30 by default we have information about 32 bits equal to 4 bytes. So it represents how we can say that it represents the row. Clear? Because this is a 4-bit field, this is a 4-bit field, and if this is a 4-bit field, what will happen? That means in 4-bit we can write any number, but length of the header is 22 byte, and 20 byte is minimum, and 60 byte maximum. We have covered about this point. How we have covered, we will tell you. Here each row is the collection of 4 bytes, and there are 5 rows, so 5 4 is 20 bytes. So we can write 5 into 4. This 4 a representation of bytes. This 5 is a representation of row. So 60 bytes, that means when 60 comes, if we add 40, what is 40? This is a option field, that means variable. Field option. Clear? So after adding this field, then we will get, so each has a 4 byte row. So here 40 numbers, that means if we use 40 bytes, what will happen? That means this is the row of 10 row. Here 10 row, 1 2 3 4 5 6 up to 10. There are 10 row. Now each row, in 10 row, what will happen? each row, what will happen? First point. Now here this is 60 bytes, that means there are 15 row and each row has 4 bytes, so there are 15 row, so this is a symbol of 4 bytes are each row, length of each row, and there are 15 row, availability of 15 row. Now how can I represent these things in a single information, that means 4-bit field? Now here first we will write a 4-bit field here. Suppose that this is the 4-bit field. Clear? Now what will happen here? 4-bit, that means we have a choice 2 power 0, that means we will write in a different manner here 1 2 4 8. Now here at 1, if we choose, because there is minimum 20 bytes, can I represent these things in 20 bytes? Yeah, yes, because 20 bytes 20 bytes equal to 5 into 4, and this is the row, this is the row. So we can represent this row in here, we can represent this here. We want to write 5, what will be 5 here? 5, when 5 come, 5 row, when come 5 row, that means here 1 availability, here 4, here we will write 1 1, then remaining term will be 0. So this is the number of 5, this is the number of 5. Now if we want to represent 15 row, how can I represent? Now here 8 4 8 4 12 12 2 12 2 14 14 1 15, so we should write 1 1 1 1 here. This will be, after adding we will get 15, so this is the symbol of 1 1 1. This field, that means if in this field, in do field, that means data offset field, if there is the number 1 1 1, that means 15 row, then we can say that the data header length of the header will be 60 bytes. If there is 20 bytes, that means there is a representation of 5 row. If we use 10 row, suppose that if we use 10 row, then here will be 8 to 10, so 1 here and 1 here, 0 0. This will be representation of 10 row. Clear? This is the understanding. Every point is clear about this. Now here sometimes why we use this 4, do you know? Just as a scale, so we can say that this is a scale factor, this is a scale factor, this is a scale factor. First point is that this is a scale factor. Clear? Now this is the whole information about data offset we have covered. I think you will have a basic and detailed and depth understanding about data offset, and everything is cleared here. Now we will tell you about reserved bits, and here reserved bits, what will be the reserved bits. Here we will tell you. This is the very important point, and it is not essential. Basically here we are joking about reserved bits. Name is defining everything. Here reserved bit, this is all data offset was 4 bits, and now it is also 4 bits. This flex is 8 bits, and this will be 16 bits. Clear? So reserved bits. Reserved. What says about this field? This is a 4-bit field. Now this field is used to set off control bits. And used for future use. This is a set of control bits, and this is reserved for future use. This bit is reserved for future use. Now that means must be 0 in generator segment. If you generate any segment, this bit will be 0 because this is for future use. So generated segment will be 0. Here generated segment must be 0. That is the point. Now that means if there are no implementation, then we always take as a 0 for reserved bits. Clear? This is the whole understanding about reserved bits and data offset. Now in next video we will tell you about flags, and if there will be a remaining time, then we will tell you about window. Clear, guys? So thank you for your dedication and patience. Thank you, guys.